Hello everyone, welcome audible. Not many people right now, so uh, I'll be back in a minute. I just have to prepare some things. I'm back now. So I'll just give a small introduction to this. So this is gonna be my first live stream, and it's also first or second video actually, but it's the first video for logic gates and something not exactly science related. It is part of STEM, but it's not fully science. Anyway, this is going to be one of the first videos for explaining computer logic and stuff related to logic gates, uh, truth tables, and building a computer. Not physically, but just explaining how a computer can work. Now, this is going to be a live stream, so of course, I am speaking impromptu. So I am going to make some mistakes. However, you can correct them in the comments, and I'll try to make videos posting those corrections. So I will be explaining today about logic gates. Just give me a minute. Anyway, I'll try to share somewhere. Give me a second. I have to get online. Not online, but OneNote on. Give me a second. Small issues, but they'll be resolved. Anyway, uh, so I'll be sharing a screen. I'll try to explain uh, there. I hope. Yeah, I can show. Now let's discuss first what are logic gates. Okay. Uh, okay, wait. I'll just have to finish this. Now I'm going to explain about logic gates. So first, what are logic gates? Okay, we have to ask that first. Now, we all use computers, electronics, and all devices, right? Well, I am using this device right now to live stream to you all and speak. People may be using laptops, phones, even television or smart TVs to see. So, to be fair, electronics come everywhere. I can even pull up a calculator right now and calculate something. But all of these need electricity, and as far as I know, electricity is not living, so it cannot perform calculations. They are different from humans performing physical calculations, like, for example, 11 plus 23 is equal to uh, 34. Apologies for this bad handwriting, I'm using a mouse. So it's different from uh, electricity is different from humans as they cannot think and explain the answer. However, what we can do is use math to exploit electricity and make them uh, do math. So, how did we do this? We simply added this one here. That reminds me, I made a mistake. This should be 32. And we add this 1 and 2 here. So, this becomes 32, right? So, we can also exploit electricity in a similar way. Now, the one way we can do this is simply turning it on or off. If you know a circuit diagram, then you'll have something like this, right? This is a bulb, there'll be some battery, and then there'll be some switch, right? So if this switch is off, then this will be off. But if this switch is on, then this will also be on, right? Now, this is a very basic circuit, as most of you know. But this gives us something important. We can switch between two states, on and off, with a single switch. So this is somewhat important because there are two states, on and off, high and low, or in math terms, 1 and 0. This is a somewhat important concept in binary, which I'm gonna write by bin, because writing full thing with mouse is incredibly painful. I may switch to phone or like actual notebooks later, but for now I'm just gonna suffer with laptop. Anyway, uh, binary is simply 1 and 0, and binary is not very different from decimal, the system we all know and love. It uses simply 10 numbers, 0, 1, 2, and so on until 9, right? But after that, there is no 10. So now, logic gates, we can get to those. So what are logic gates? Well, they are somewhat what they seem, logic gates of logic. Gates simply allow or not allow things. Some things may not go, and some things may go, right? And logic is basically some rules that this will follow. So logic gates are quite literally gates of logic. So what we need is some way to turn these zeros and ones to some meaningful thing, right? I mean, I cannot have some logic gate which has randomly, right? If the decision of allowing something is just by a roll of dice, then that's near useless, right? We want something controlled to uh, make some decisions and problems, not problems but solutions. So now, uh, 1 minute. One small problem I have. Yeah, apologies. So as I was saying, we don't want random things, right? We want some predefined rules or logic that allow something to pass or not pass. So we can determine what the answer will be. This deterministic nature of logic gates can help us build things like calculators, internet, and even AI. AI is simply math, which is smart. Not smart, but clever. So now let's actually get into logic gates because I've been blabbering about what logic gates are. So mainly logic gates are two internal values, so A and B. Then there will be something that acts on them, and then we get some answer C, right? So in maths, this is kind of like a function. You have f of A and B, and that gives you C. So logic gates are somewhat similar to this, except that in math, A and B can be quite literally any value, while in this normal computers, A and B have to be either 0 or 1. Okay, there's not proper way to say, but this can be 0 or 1 or backwards. Now let's go to our first logic gate, AND gate. Okay, and this is the first logic gate. Now, what does and do? Let's go to something less similar to this, and let's talk about English. Let's say I give you a sentence. Uh, I go get some water for me, and I'll give you a cookie. Okay. So, so get a cookie, and I'll give you. Sorry, get water, and I'll give you a cookie. So now, what does this mean? Let's take 0 as not done and 1 as done, okay? To make things easier, we're translating from math to English. We need some way of making that jump, right? So now, uh, let's see. If we have uh, get water, which is not done, and give cookie, which is also not done, then this will be false, right? Has this been done? No, it's not. Now if we do, let's say, the cookies, the water is not given, but the cookie is given, then it's also false because this violates what we said. Only if you get water will I give you a cookie. Now, if we take the reverse scenario, they get water, but we don't give a cookie. That's also false or bad because they did what you asked, but you didn't uh, do anything. However, this also violates. However, if they give water and you give them a cookie, then it's true. That is, you have uh, done the conditions. This is fully true. So now this is the logic behind AND gate. And what we've made here is something called a truth table. What we've done is given the inputs and the result. Okay. So here's also introduction to truth tables accidentally. So we have values A and B, and we'll also have C. Then what an AND gate does, we call this the truth table for AND gate, would be it checks if both the numbers are positive or not positive, just one. Okay. So if both the numbers are 0, then the output will also be 0. If only one of the numbers is 1, then the other's number is 0, right? So it's still 0. But if both numbers are 1, then the answer will also be 1, right? Now, uh, you might notice something if you like maths, or even if you don't, if you just do maths. This is somewhat similar to multiplication, right? 0 times 0 is 0, 0 times 1 is 1, 0 times 0, 0 times 1 is 0, sorry, 1 times 0 is 0, and 1 times 1 is 1. So this can also be represented as multiplication. So one way of writing this in Boolean algebra, I'll tell what that is in a minute, is A B. Okay, this is A and B, same thing. These two are the same. Okay. Now, there's also a technical third way of writing. There's first Boolean algebra way, or just multiplying the numbers. There's the writing form, or English form as I like to call. There's also third form, symbol form. The symbol for and is something like this. Now, you remember how I said a logic gate is something like this, right? Well, this is also strikingly similar. This is A and this is B. This is the input for A and this is the input for B. And this will be C. And in real life, this is actually more or less correct because what are the inputs? Simply wires, right? They carry some information, either electricity or no electricity. And then they will, these AND gates, they cannot be just magically created and automatically decide, right? No, there are some circuitry here. So I'm just writing electrical magic, but it's not magic, it's simple circuitry. You can actually build it at home. Even I'll show how later. And then you will get some wire coming out with electricity or electricity. Here, because it's 1 and 0, it checks if both numbers are 1. So this is false, right? So the output also we get false or 0. Now let's think about how can we build this in real life. Okay, let's take our battery and let's take this bulb, right? Now I need you to go back for a bit and remember this. You know that light bulb example, right? That was a very simple type of logic gate which simply allows electricity if there is any electricity, right? Very simple. The logic is if it's on, then it'll be on. If it's not on, it'll not be on. In memes, this might be called "it is what it is." So what we can do is that because this one is a logic gate, two of them can be combined to make a logic gate. So how do we make this an electrical engineering? Well, let's think for a bit. We need both of the inputs to be one, right? And we can also take open as 0, the state of being open as 0, and the state of not being open as 1. So what does that mean? Only when both switches are closed can the output be 1 or on. So very simply, we can take one open switch and connect it in series with, okay, that's new, with another open switch, and then connect that to a light bulb. So if I close this, nothing will happen because this is open. If I close this, nothing will happen because that one is open. If I only close this, that is. And if I don't close either, well, it's all always open, so nothing happens. But only when I close both, only when both are one, does this bulb light up. So this will also be one. So that is a very simple physical form of AND gate. And there's also a way to make this on very small scale with transistors, which are basically tiny electrical switches, but I am not going to talk about them now. And now let's go to Boolean algebra. Okay. Now, what even is this Boolean algebra? I just dropped a bomb shell on you about Boolean algebra, and I didn't even talk about it. Well, let's see. Boolean algebra. Let's talk about the Boolean part. What does this mean? Well, it's simply binary. Yes, mathematicians and computer engineers, they like fancy words for everything, but this is basically binary algebra. This only deals with two numbers, 0 and 1. And algebra is simply, not finding unknown, but basically manipulating the numbers in however way you want. Give me a second. I see a lot of people have joined. That's nice. Nice. Anyway, uh, basically, all in all, Boolean algebra is manipulating these ones and zeros, or more specifically, another way of representing logic gates. Okay. Now, let's talk about this AND gate. We showed that AND gate in Boolean algebra. I'm just gonna say it BA will be. If you remember, I think most of you joined late. So let's recap. It's multiplication because it checks if both numbers are one, else it will give zero, right? This is very similar to multiplication in maths. If you have zero times some number, you will get zero. Okay, so we're just gonna say it as AB. Now let's talk about the second type of logic gate because this is the first one. The second one is OR gate. Now this is a very similar thing. Let's take another example in English. Do you want tea or or do you want coffee? Now let's talk about the result which they say. If you're giving to some guests, you may have already experienced this a lot. If they say no to both, then you give nothing, right? If they don't ask for anything, why would you give them something? If they ask for coffee, they'll ask for something, so you give them something, right? If they ask for tea, then you give them something, that is tea. But if they say I'm fine with anything, that means they say one and one or one and one, then you can give them anything you want, right? You can give them tea or you can give them coffee, okay? Whatever you have in your kitchen. So this is also similar to this OR gate. It simply asks, is one of them one? So it asks, is A one or is B one? So if neither of them are one, then none of them is one, right? False. A is one, but B is not. So C is one because one of them is one. That condition is valid. If A is not one, but B is one, then the condition is also valid because we're just checking if one of them is there. And if A is one and B is one, then both are one. So of course, condition is valid, right? Now, this is again similar to something you might know in maths. Can you guess what it is? Type in the comments if you know what an OR gate is similar in maths. Slow news day, I guess. But here, an OR is very similar to addition because 0 plus 0 is 0, 1 plus 0 is 1, 0 plus 1 is 1. But now we step away from maths and enter Boolean algebra because 1 plus 1 is not 1, it's not 2, it's 1. I'm sorry, it's actually 1. Basically, we're checking if two things are true, is the output also true? In OR gate, that will be yes, it is also true. So now we have two ways of noting it down. We have English way, which is with an actual or, A or B. We have with Boolean algebra, Boolean algebra, which is A plus B, and then we have symbolic, which is this symbol. Okay. Now, how can we build this in physical form? Okay. I should also note this down that AND gate cannot be built in physical form, as I said. So we also need a physical form. So what's the fourth way for physical form? Can anybody say? I'm gonna just take a drink of water. Anyway, the physical form. Let's go back to cell and what's this? Bulb, right? That is much more useful. Now we need only one of them on, right? So we need something like parallel. So if one of them is on, then the whole circuit is also on, right? So what we can do is something like this. I will need a bigger uh, part of the board for this. So we need parallel, right? So let's take this switch here, and then let's also make a diverging path for this switch here. Okay, I have messed up a bit, but let's make it like this. Now we can join these two together and make the bulb. Now why does this work? Well, let's see. If we close neither of them, it's of course open. There's this line running through them, so it's open. If we close this one, then the electricity has this path to go through, right? And you, of course, if we only close this one, then the electricity has this path to go through, right? Even though this is open, it's still connected with the bulb. And if we close both, of course, it can take any one of the paths, right? Why is it called Boolean algebra? You joined a bit late. A second, there are some problems I have. You can do one of two things. You can first rewatch the stream after uh, after I finish the stream, or second, I can explain you now. What do you prefer? And also, sorry, I'm ignoring you because I have to look at another screen, and this whole thing is blocked for me, basically. It is a bit important, but I'll just explain because it's also a bit short. Boolean, let's talk about Boolean algebra once again. Boolean algebra, Boolean part, it's simply relating to binary, okay? It talks about only two states, 1 and 0. And algebra talks about the rules for manipulating these and how they interact, okay? So one rule of Boolean algebra is 1 plus 1 is 1, actually. Now, this is very different from both binary and normal. Normal, you will have 1 plus 1 is 2. Binary, you will have 1 plus 1 is 1, 0, or actually 1, 0. However, in Boolean algebra, we don't talk about 1 and 0 as numbers. We talk about them as true and false. That means this plus sign we are saying as either one, and 1 we are saying true, 0 is false. So we're checking, is either one true, or gate is asking that. So here we have, yes, one of them is true, the other one is also true, but we just care about at least one. Then that means the whole statement is true. Therefore, in Boolean algebra, 1 plus 1 is true, or just 1 plus 1 is 1. Now we have this or physical form. Now let's go to the other gate, which is called a NOT gate. I hope most of you know what a NOT gate is, even without computer science, because it's the same as English. It basically negates or reverses the sentence. Let's say there's Soham, okay, pretty nice guy, and then there is not Soham. I'm tired of using the mouse all the time, so I'm just gonna write short form, not Soham. Well, Soham refers to few people, one of them including me. Not Soham refers to people who are not me, basically everything else. Okay. Now, this is where the Boolean part of Boolean algebra comes into play. Now, let's take A and then not A. Let's take C. This is actually only a one, what's this, input function. Like, for example, the previous ones are called binary functions, actually. I feel like you know why, because there are only two things, 1 and 2, okay, or just 1 and 2. And then this will be called monomic functions. I'm not sure of the exact word, but it's something on the lines of monomic or urinary or I don't know the exact word, but unitary functions. I'll just call them unitary or monomic. Okay, sorry if I don't know, but if you know any person, or if you know who knows the actual name, please tell me. Maybe unary. Anyway, what's the case? This is a one input function. It takes the number and then reverses it. Now, here's where Boolean helps. Boolean. What did I say Boolean was? Can anybody tell? Very slow news day. Anyway, Boolean is basically 0 and 1 or binary. So that's pretty neat. We have only two values to choose from. So if we have one value, we cannot use that value again because Soham is not the same as not Soham, right? Now, yeah, that's true. It's basically 1 and 0. So for 0, we need to have 1 as the answer. That's the reverse. Or basically low and high. I hope you can see low and high and low. So therefore, 1 will be knotted and become 0, basically reversing. Now, this is not gate. I will. Oh, that's new. Not gate can be written as first thing as actual words, not a. Second, it can be written as. Now, this is another part of the Boolean algebra. The symbol for this, oh my god, the symbol for this will actually be a with a dash over its head. Okay, shout out for who? Ayan, ha, don't worry, Ayan, you'll be a topper. Tissue also. But that aside, logic gates are tissue. I called you out. Don't worry. Uh, Logic gates are more important than both of you. I'm pretty sure laptops and computers are more important than both of you. Anyway, Boolean algebra states that the symbol or the uh, picture for this will be a with a dash on top, basically a negating. This is similar to set theory. Not many of you may know, but in set theory, it's like the complement of a set with a dash or with a C on top. It's basically everything but what is the number. Okay, we can take the number as a singleton set and universal set as the rest of the things, and so we can take not as the what is this complement of the set. However, here universal set is basically both 0 and 1, while a is one of these numbers, so the complement will be only one of them, of course. Now there is also symbolism form, which is actually like this. Okay. Now, give me a second. I have to check with the book I have. It's actually been a long time since I've done this, but yeah, this is not yet. Now, I'll tell you in a bit why it's like this and not simply a triangle. Why it add the extra zero. Now, this of course takes a and spits out not a. Now, there is another way to show this, and of course, that's in electrical engineering, or I'm just going to call it circuits. Now, let's take again our battery and our bulb, right? Now, let me go back to something before. This thing here, what we saw was this. There's only one place where we can enter a value, right? We can enter closed for this, or we can enter open, right? Only one place we can do. And here we can enter in two places, closed open and closed open, which is similar to this, right? The input pins. So we can say as one of these switches as an input and the bulb as an output, right? So now here we can take this number also as a switch. So that therefore that means there's going to be only one switch. Now, where do you suppose that one switch is going to be? So that if there's no input like a0, or if the number, sorry, not number, if the switch is open, because 0 means open, what will we get? You'll be surprised. Anyway, no, we're not gonna go to Minecraft yet. And That's an example. So here we have this circuit. Where should we put this switch so that we can have no current when there is a closed switch and current where there is no closed switch? CR7 or 10, I have no idea. But please tell me genuinely, do you know, or are you just staying here for laughs? The question is that where should you place the switch or connection here so that the bulb will be on if the switch is open and the bulb will be closed if the switch is closed, or the bulb will be off if the switch is closed. Can anybody tell? Okay, you are all struggling, so I'll say. Now, you may know something called path of least resistance. Basically, electricity tries to take wherever is the least resistance. So, if I have two circuits joined together and same output, then if the black one gives more resistant and the blue one is less resistant, then the electricity will mostly pass through this blue one, right? So now we can do something similar. A bulb will have resistance, but a switch has nearly zero resistance. I hope you have learned that. So what we can do is put the switch directly here. So now what does this do? I am not trying to be racist, my guy. And if the blue one gives more resistance and if the black one gives less resistance, then the electricity will travel to the black one and not a lot to the blue one. That's path of least resistance. Whichever gives less resistance, electricity will favor that more. So now here we have electricity and a closed switch. Now here current will pass through this, right? Why? Because this has nearly infinite resistance, or it's open, right? So no electricity. So this will glow, right? However, when this is closed, what will happen? A short circuit, because this has zero resistance. This will more likely pass through here and not go through here. So this will be off. So now we have a way to show NOT gate as an electrical circuit. In fact, I encourage you, one of you, or at least one of you, that's an application of OR example, you can have some circuit and you can actually make it physically. So make a video and post it with a mention to me. I will see it and I will use that an example hopefully for my next video or next videos if you're uh, if you explain it well also. Now, uh, what are next? Well, these are all the basics, right? Well, there's also one more. Sorry, there's a buffer. Okay. Now I'm gonna entertain someone's request, but not in the way they expect. Okay. All of you know Minecraft, right? Now in Minecraft, if you have done some redstone, there's something called a redstone repeater. So what that does is simply boost the redstone signal up to max capacity, which is 15, and it just repeats it, right? That's why it's called repeater. Now buffer, it does something very similar. Tissue, there you go. Transition to Minecraft. You never said play Minecraft before, technicalities. But yeah, buffer does something similar. If you have A, what a buffer is gonna do is it's simply gonna allow A to pass through, right? Give me a second. Yeah, a buffer is going to allow that to pass through. This is why that NOT gate needed an extra circle on the triangle, because a buffer already claimed that symbol. It simply repeats and it actually is shown right here, right? As you know, it is what it is. That is very simply a buffer. Which optional is this? This would be CS. We are going to learn Boolean algebra, at least in my school. So I'm just doing this because I like it, and uh, what is this? I want to explain it to others. Yes, I'm studying CS only. Now, you know this is CS, yeah. What about it? Now, just very quickly, the buffer is this correct? So, like, is this correct? If it's false, right? If it's true, it's true. So that's very simple. So similarly, buffer. If it's zero, if it's zero, it's zero. If it's one, it's one. So that will be A and C. That's very simply buffer. No, it is in the syllabus. It is Boolean algebra and what is this? Logic gates. So this will come at least in CBSE and CRTA syllabus. So now these are all the main gates, and also how you can make the electrical engineering. So I may just stop it here because my notepad space has run out actually. That's pretty interesting. Anyway, I will entertain some doubts. So let me make uh, that's the wrong thing. Give me a second. Yeah, so I'll be entertaining some doubts about this. So you can ask about all of this. I just realized I this is wrong. So yeah, tell me your doubts. I will accompany you in a minute. Yeah, uh, if you can ask questions now because I know some stuff, so I can explain it to you now also. So, as passive viewers, you may not understand, right? So, ask now. I'll try to explain. I don't care if he's giving me threat, but don't worry, I'm at your school, so I'll see him. Anyway, tell any doubts you have. Brother, doubts related to what I asked. Will you ask, what is this? English, ma'am, why Hitler went to war? I'm going to try for football. But some questions actually related to what I just explained, please. I'd appreciate that. Why is it so small? Explain circuit wala switch. Okay. Explain what circuit. Can you say what circuit? Or should I explain every circuit again? I couldn't go on tangent and explain circuit, but sure, I'll explain circuits because why not? Anyway, I'm gonna explain first. What's this? I'm gonna explain first circuits and what is this? Short circuit. Okay. So first circuit is basically a collection of electrical components, which is not very useful. So what I like to call it is and what's this? Collection of something that gives power and something that shows power is being used. So if we have a bulb and a battery, which I started drawing in the reverse order, then this will be an electrical circuit. Very simple. Now, the flow of current, this is a pretty interesting one. I'll go a bit into a history background. Now, Benjamin Franklin is an American who had one of the first ideas for electricity. He thought it was a liquid, okay? And before times, positive was considered good, negative was considered bad. Right was better than left, or right was better than left. So now what he thought was that electricity was a fluid that flowed from positive to negative, okay? And it just had that nature. It wanted to go from positive to negative. Now, this is what we call conventional flow of current, okay, CFC. No, this is not chlorofluorocarbons. This is conventional flow of current. Now, uh, what we found out later was that Benjamin Franklin was very wrong. What the problem was that he made this in the 1700s and 1800s, and we found this out in the 1900s. So people had been using this for around hundreds of years, this convention that it goes from positive to negative. However, what we found out that electrons were not positive, they were negative. So then that means they went from negative to positive, right? So that means this whole thing is wrong. So actually what happens is this. I'm drawing the circuit again. Electrons, because they're negative, they go from negative to positive, right? And that is actually what makes the bulb glow. What we call this electron flow of current, EFC, I'm calling it right now. Do not use these acronyms in your exam. I am just saying this because writing the full thing is very painful for me because mouse. Anyway, because people had been using this convention for a long time, we decided to just stick to it at school level, okay? So we stuck with this, but this is actually what's happening. Electrons are flowing backwards from negative to positive. What I'm going to do is basically switch between these two because I can't be bothered to remember which is positive, which is negative. But now let's go back to the short circuit, right? What's a short circuit? Well, it's in the name, okay? It's like EA Sports, it's in the name. Let's take this, okay? Let's go back to a bit of your high school or middle school. Let's say this is around 20 kilo ohms, okay? Kilo ohms. Now, electricity passes pretty slowly through this, right? Also, I'll give you a shout out if you identify what type of current flow this is. Now, here, this current moves pretty slowly because, V is equal to IR, right? Or arranged is I equal to V by R. If V is high, then if R is high, then I will be low, right? It's inverse proportion. Now, here's a problem. Let's introduce a stray connection, okay? Like 0.01 ohms. Now, R is pretty low, so I will jump up, right? It'll be very high. This actually explains what is this? Path of least resistance. So what will happen is that electricity will flow very fast. Now, there's also another thing that says heat is uh, proportionally or directly proportionally to I square, okay? So heat is proportional to I square, which means if I is very high, then heat will be very, very high. Okay, I'm not explaining in proper terms, but what I'm saying is that this will be very hot. Okay, so that is what's called short circuit. When the electricity has a path of lower resistance or a shorter path, it starts flowing through that, and that is called a short circuit. So for the reasons, actually making a NOT gate is slightly dangerous. Why? I'll explain again. So how do you make a NOT gate? Can anybody say? I'll draw the simple diagram here. Can anybody tell me how to make a NOT gate? How many slow news days are there? Anyway, uh, let me just get to the point. This will be the NOT gate. Okay. If this is open switch, then electricity will flow this way, right? But if this is a closed switch, electricity will flow through this because it's less resistance. Does this look familiar? Exactly, it's a short circuit path because you're making a path of lower resistance or a shorter path, which is making the electricity flow through that instead of what you want, the bulb. So this basically gets us to what we want. We get the uh, shorter path, we get the electricity on the shorter path, and therefore the light bulb does not light up when the switch is closed. However, when the switch is open, the path is not very short, it's very long because there's infinite resistance, basically no current passing through. So instead current has to pass some through somewhere and get to its starting point, right? It's like a race. So the only path it has is through the bulb. So the bulb glows. I hope you understood it then. I might make this a 1 hour stream. So that's the first question answered. And also second question I can add here as explain short circuit. So do you have any other questions? And also, how are you liking this? Is this good? Yeah, am I explaining well? Any feedback? Yeah. Bye. So, as a conclusion, I'm just gonna go over the topics once again. So, what did we do today? Well, we explained very simply what binary is. We explained what logic gates are. We explained what Boolean algebra is. I think I should explain right now. Binary is simply ones and zeros. That's a number system where we count in ones and zeros. I will explain this later on, so don't worry if you don't understand it now. I also explained what logic gates are, quite literally gates of logic. They have some logic that allows stuff or outputs to go through. So it's like what's this, actual gates which allow people to pass and not pass if they what's this, fall under some actual what's this, conditions. Sorry, I'm stuttering a bit. Then Boolean logic is simply binary. Sorry, Boolean algebra is binary maths. It's about true and false and how you can manipulate them and what their relations are, how they interact with each other. I do not understand tissue like China Matson. Tissue tissue जैसे चिनारों की Matson. I have no idea what you're talking about. So sorry. Anyway, what was I saying? Yes, we also explore types of gates. AND gate, which checks if both inputs are AND gate checks if both inputs are true. So if only A and B are true, then C will be true. Its symbol is like this, and what's this? The circuit diagram is like this. Second, we have OR gate. It checks if at least one of them is true. So if so, all of this give true. At least one of them is true. So then the Boolean algebra form is this: a plus b, and is a times b, and the circuit diagram for this is like this. And also the pictorial representation is this, while pictorial representation of and is this. I may be missing some things now. We also explored NOT gate, which simply negates it. 0 becomes 1, 1 becomes 0. If any of you have seen Project Hail Mary, left is right, right is left. Xenon is a metal. Its Boolean algebra representation is this. its symbol is this, or just a pictorial representation is this, and it can be, what's this, circuit diagrammed in this way, or I can show better here. This can be the circuit diagram. Now we also explored one last gate, okay, this buffer gate, which basically lets stuff through. Zero remains zero, one becomes one, or one remains one, and it checks whatever the input is, and it gives that as the output. Not very useful. Buffer, I don't know if there is any Boolean algebra representation for it, for buffer, but what I do know is that it simply just looks like this, the pictorial representation. And buffer circuit diagram I showed at the start, actually by accident, or by accident, you never know. It's this, simply a battery connected to a switch connected to a bulb. So now, uh, give me a second. Yeah, it does not have any symbol or a representation. 1 minute. So yeah, this is a buffer. It simply repeats whatever input you give it, and that's about it. That is actually part 1. So sorry if you clicked on this video thinking will explain everything of logic gates. I may have to rename it, but it is part 1. Okay. We also did some Q&A, very simple, explaining explanation of circuits. Conventional electron flow is the one which Benjamin Franklin thought. Electricity goes from positive to negative, so positive to negative. However, what is actually true is electron flow convention, electron flow current, sorry, which goes from negative to positive, because electrons are negative in nature, so they go from negative charge terminal to positive charge terminal. And then short circuit, it is the phenomena where electrons or electricity, they start flowing through a wire which has lower resistance than the wire it should pass through. So here I have battery, a wire of point zero 0.01 resistance or ohms, and that makes electricity pass through that instead of the 20k ohm bulb. So yeah, that's about it. Not many people, at most 3 people today in the live stream, but that was pretty good. So yeah, now some more things. This is actually my first live stream, as I told at the start, but it went pretty well. So what I'm gonna do is I'm gonna continue the series. Okay, I'm gonna continue about logic gates, and as one of them said, this show I believe, with what's this? With joy to him, I will actually be doing something related to Minecraft. Okay, now that Minecraft part, it's gonna come much later. Okay, I'm also going to show some things related to logic gates, not online, but you can use it later. And I will be teaching small things. I am not actually fully licensed professional, but I explain pretty good. So please support me. If you like this, of course, like and subscribe, and also put the bell notification icon, so that when my next video comes, you will be one of the first to see it. Same for live streams also. Now it has become late because I'm actually based in India. So that's it for today. I will explain more gates, because 4 is not the only number of gates. I will explain more gates later, and I will see you in the next live stream. So bye bye. Hope you learned something new. And that is Soham Science Bites signing off. I actually sign off in a few minutes because I want it to be 1 hour. So yeah, some people of my school actually joined, so that's pretty nice. Shout out to Ayan and Tisho again, and yeah, I'll see you later. Bye.